Hello everybody. Today I'm going to demonstrate to you an ion motor. Now an ion motor is a device that simply uses charged ions to spin a blade. So what I have here is this long tube that has a simple circuit that converts DC electricity to alternating current. That alternating current is going to go through a transformer, and as it goes through that transformer the voltage increases, and that voltage is going to be responsible for charging many capacitors within this tube. Okay, so there's capacitors in this tube that are connected in such a way that they're going to charge in parallel and discharge in series. So what that means is when they charge in parallel, they're all going to have the same voltage, and then they're going to discharge in series, meaning all those voltages would add up. So this is what's called a voltage multiplier. It's going to be able to create sparks about, I'll say about 2 centimeters long. So that kind of shows us exactly what kind of voltage we're dealing with here. What I also have here is an electroscope, an electronic one. And what this will tell us is what sort of charge is in the vicinity. So right now this is set for negative charge, sorry, it was set for positive, now it's set for negative. And what I'm going to do is put this device on and show you how it works. Now the principle behind this is that charge is going to want to accumulate on sharp points. Okay, and so on this blade there are two very sharp points here. Okay, and these sharp points is going to help ionize the air because charge is going to accumulate on those sharp points, ionizing the air around it, and as it ionizes the air around it, that's going to force the air to repel away from the blade. And because of Newton's third law of every action there's an opposite and equal reaction, that's going to cause the blade to spin in the opposite direction. So what I'm going to do is I'm going to spin this blade in the direction that it's not supposed to spin, and so when I plug it in you're going to see it slow down and then speed up in the proper direction. So typically this, because the needle point is right here, we can think of the ions as coming off that needle point, forcing this to spin in this direction, which would be counterclockwise. So I'm going to spin it clockwise, plug it in, and you'll see it slow down and then speed up. Alright, it's plugged in now. Okay, so you saw it slow down, and now it's speeding up. And we can see with my electroscope here that nothing is going on, and the reason why nothing's going on is because this is actually putting out positive ions. And this is set for negative. So if I flip this to positive, now we can see that the needle point is moving and the light is flickering. So let me just kind of zoom in on that so you can see for yourself. Okay. So we can see that with the switch to positive, the light's flickering and the needle is moving. Okay, so that again, that shows that we have positive ions being released by this ion motor. Now just to show you exactly how much voltage is involved here, like I mentioned, there's about 1 to 2 centimeter sparks that can be made with this. So this is the grounding pick. This is going to be negatively charged, and I can see that with the electroscope that if I flip this to negative and then I bring this close to it, we can actually then see it kind of activate and see the needle move and the light turn on. Okay, so flipping this back to positive so you can see that this is still spitting out positive ions. So when I bring this close to the blade, you'll see the spark created like so. So we can see that it's about 1 to 2 centimeter spark being created there. So that kind of gives us an idea of what kind of voltage is involved. Okay, so a lot of charge to help this spin pretty fast. Okay, and that's it. I hope you enjoyed this video, and I will probably be posting another one soon looking at St. Elmo's fire. Till then.